Hello, Jeremy here. Today I'm going to go over basic computer architecture and try a little something different and have a hand-drawn diagram here. So what we're seeing here is a very simple basic computer layout. We have the components, the CPU, which is the central processing unit here. It's responsible for doing the processing of the data. So also controlling the addresses, and there's these control lines. There's the RAM, which is responsible for storing memory. RAM stands for Random Access Memory. CPU stands for Central Processing Unit. Then we have a keyboard device here. We have a mouse here. We have a monitor down here. Now, those are the components that are connected to this simple computer. So these are electrical connections between the CPU and the different devices. So we have three different kinds or types of electrical connections. You'll have the control lines, the address lines, and the data lines. The control lines will say, okay, it's time to read, okay, it's time to write, and also enabling the ability to do a transfer. So that's what the control is mainly for determining read or write. The address lines determine what address we are talking to. This is kind of like an address for a house, like your home. However, we're addressing, let's just say, bytes for this case. This is a little tiny 8-bit CPU, and it only knows how to handle bytes. So this RAM has addresses 0 through 1000 here. So this thing can store 1001 bytes. Yeah, I think so. So in the next is the keyboard. This is 1001 to 1100. This is the mouse, which is 1101 to 1150. And then the monitor is 1151 through 1400. So if you want to communicate with the RAM, we have 1000 or so bytes that we can address and read from the RAM. On the keyboard, we have around 100 bytes that we can read from the keyboard. I'm not sure exactly why it needs to be so big. I just made up these numbers. The mouse has about 50. The monitor about 350. And the monitor makes more sense because you want to write the pixel data to the monitor. So that makes some more sense. Okay, so how this works in general is the CPU, like if it wants to talk to the first byte of memory, it'll address 0, which addresses the RAM, and it addresses the 0th byte. So it's kind of like the 0th index of RAM memory. So let's say, that could be, I'm trying to get some light out of my pencil. At address 0, that could be a 5. Great. And the control says read, so there'll be a 5 on this data line, and it'll read in the data of 5, and it has to store it into one of its internal registers. So this is usually determined by the instruction. I'm just going to say it's an A. I'm going to put it in A. Brilliant. Okay, so the 5 got read into memory, read from memory into register A. And after it's done with that, there's no longer a 5 on the data line. So now what could happen is we could do a write. So the CPU will say control will be a write, but then we'll address the monitor. So we'll address 1151. So on address 1151, we will output register A as the data line. So we'll have 5 back there again. And that'll get written to the first memory location of the monitor. Maybe that's the color or something. So the first pixel will change color on the monitor. That could be an example of what happens. So that is the fundamental basics of how a computer works. You either read or write from a memory device into the CPU, and you can write out to a memory device, to another device on your bus. Okay, I just came up with another term. The bus is this data connections, these data connections that everything is connected to. So this whole thing is like the main bus of your computer. Oh, another thing you can do with your CPU is, let's say we read in another byte from RAM, the next byte. So we address 1 on the address bus, and then we read it into B, and it is 3. Okay. Now the computer, since it has the data, the CPU has the data inside of it, we can add registers A and B. And when you add them together, you can then store them somewhere else. So let's say it's stored in C. So add store result in C, and now you have addition in the CPU. To do any kind of operation, things are pulled into the CPU, manipulated, processed, and then written out from the CPU to another device. So this is the general flow. Input goes into the CPU, it is processed, and then written out to some sort of output device, like a monitor. This can also be an Ethernet card, so you can communicate over the internet. This could be a hard drive. Also, this could be memory. You could write this 8 back into RAM. RAM is fast, so that's a very common operation, is to store things in RAM. These registers are memory, and they're faster than storing things into RAM because they're closer. They're right on the chip. This has to go outside of the chip onto the external bus. But the advantage is this external memory on your motherboard is a lot bigger. And then even more so is when you write to a hard drive, so some other device, a hard drive here. That's usually a lot slower, especially if it's a disk hard drive disk. It has to spin up the hard drive and do all those things to find the location of the data on the hard drive. And you can write to the hard drive and read from the hard drive and do all those things. So this is the basic layout of a computer. So I hope this works out, and this was actually a good method of explanation.